Good morning, everyone. I welcome you back to my YouTube channel. Presenting before you this wonderful tutorial is the mentor Hampir Kliman. And if you are new to this channel, consider subscribing, hitting the like button, and don't forget to share to others. Okay, so we have yet another practice question under dimensional analysis, but this time around we have been asked to find the dimensional formulas of the given quantities. If you have a question, make sure you inbox me on the WhatsApp line projected on the screen. I'm going to make this easy so that you should be able to know how to come up with the dimensional formulas in case you're asked in MCQs or just in essay writing questions. Find the dimensional formula of the following showing your work. So the first one that we have been given is force. So we've been given to find the dimensional formula of force. Now the formula for force is simply equal to MA. Now the whole concept is, I always say, the whole concept that you should put in your head is simply the MLT concept. MLT concept simply means the M is a dimension, okay? The M is a dimension of mass, implying big letter M. And L is simply a dimension of length, implying big letter L. And T is the dimension of time or the period, implying big letter T. This is the MLT concept, and we shall be using it for these particular questions. So, force is equal to mass multiplied by the acceleration. We want to put it in the MLT concept, but we know that the dimensions of mass is simply big letter M. The dimensions of acceleration, make sure that if you don't understand what dimensions of acceleration are, please consider watching the other video on dimensional analysis on this same channel. The dimensions of acceleration is simply L over T squared, okay, which can also be written as LT negative 2. So if we replace where there is mass, I'm going to put my big letter M. Where there is acceleration, I'm going to put this. That is how you come up with the dimensional formula of force. We come to work. Work is equal to, okay, so when work is equal to this same force over the distance, the dimensional formula of force has already been established. It is MLT. Okay, so I'm going to replace it there. Okay, I'm going to put my MLT negative 2 to the power negative 2. The dimensions of the dimensions of okay, let me just figure out something. Sorry. Okay, so we know that work done is equal to force multiplied by the distance. So in this case, we've already established for force, which is MLT negative 2. Then we know that the dimensions of D, or the distance, is simply length. So you put your length there, and of course, you're going to just multiply. So you're going to have your M. L multiplied by L, it is going to be L power 2. Okay, L power 2. And then you are going to get your dimensions, your T to the power negative 2, like that. So that is just how you go about this particular question. Okay, that is just how you go about this particular question. So you found the dimensional formula of work. Okay, let's go to the other one. Which one? Pressure. What is the formula for pressure? Pressure is equal to force over area. We know that the dimensional formula of force is equal to mLT to the power negative 2. In this case, I can put it there. The dimensional formula of the dimensions of area I explained in the other video, it is simply L to the power 2. So I can put my L to the power 2 down there. So these two and this guy is going to cancel, are going to remain with L underneath. So this is going to be M, then this L, then to the power negative 1, and then T to the power 2. These are the dimensions of pressure. We come to momentum. How do you find the dimensional formula of momentum? For momentum, okay, for momentum, momentum is equal to the mass multiplied by the velocity. The dimensions of mass is equal to big letter M. The dimensions of velocity is equal to L over T. So I can replace, okay, so I'm going to get something like, this can also be written as L T to the power negative 1. That is correct. So where there is M, I put my big letter M. Where there is velocity, I am going to put my L T negative 1. And that is my dimensional formula for that particular question. Okay, let's go to impulse. E. How do you find the dimensional formula of impulse? Impulse is equal to the force multiplied by the period or the time. Okay, so in this case we can put our dimensional formula for force, which is mLT power 2, then we multiply it with the period. What are we going to get? We are going to get something like mLT, then T multiplied by that figure. Okay, if we multiply T by that particular figure, we are going to get a negative 1 because they will just cancel like that. Okay, they will just cancel. Okay, we come to frequency. How do you find the dimensional formula of frequency using the MLT concept? Frequency is simply 1 over the period. So if we are to use the MLT concept, let me show you. If you want, you can just say M L T in advance. Then you ask yourself, what dimension do you have? The only dimension that you have is for the period or time, which is simply a big letter T. So in this case, you do not have the mass, so your mass becomes 0. Anything raised to the power 0 gives you 1. Okay, your L is not present, you can put a 0. The only thing that you have that is significant is period, and in this case period is underneath. Okay, so it is going to have a negative 1, and that gives you the dimensions of, the dimensional formula of frequency. It's quite very simple. G. What are the dimensions? What is the formula for area? Area is equal to L times some distance. Now, in this case, the dimensions of length is big letter L. The dimensions of some distance D or whichever you can use, X or D, is simply L. Okay? It is simply L. So in this case, we can say that where there is L, I'm going to put big letter L like that, multiplied where there is D, and L like that, and I'm going to get L power 2. But using the MLT concept, I am going to show that the only thing that is significant is a 2 there, a 0, and a 0, and I write my dimensional formula. H. That is how you find the dimensional formula of these particular physical properties. Then we come to the volume. V is equal to L times B times H. The dimensions of L is big letter L. The dimensions of the base is still some distance. Dimensions of H is still some distance. In this case, I can put my L there, multiplied by my L there, multiplied by my L there, and what I'm going to get is L power 3. Using the MLT concept, this is not significant. We do not have the time, but we've got the length, and it is to the power 3. Henceforth, that becomes our formula. Next, density. Okay. How do you find the dimensions of density? What is the formula for density? Density is simply mass over volume. What are the dimensions of mass? It's big letter M. What are the dimensions of velocity? It is simply L over T, or L T negative 1. We can replace and find our formula. So this is going to be M over, this is going to be L over T. So if we do our multiplication there, if we do our calculations, we are going to get something like, okay, we are going to get something like the density is going to equal to, for using the MLT concept, the mass there is 1, like that. Okay, the mass is going to be 1. How about the period? The length is going to be negative 1, and at the same time, period is also going to be negative 1, like that. Let me see. Sorry. Okay, sorry. Okay, so I mistakenly visualized the V for velocity. Sorry. So the dimensions for mass is big letter M. Please don't you ever make this mistake in the exam. Most students make this mistake in the exam. This is the volume, and we mentioned it is L to the power 3. Okay, so L to the power 3, henceforth, using the MLT concept, the M, please don't make the mistake that I made in the exam. Okay, make sure that you know what you're dealing with. You can make a mistake visualizing your V for volume or your volume for velocity. So make sure you know what you're dealing with. The mass in this case is 1, our length is 3, our time is not significant. Henceforth, this is the dimensional formula for this particular question. We go to okay, let me see, velocity. we go to velocity, which is simply J. So velocity is equal to the distance in meters over the time in seconds. Oh, I'm using units. I can use whichever. I can use units. I can use the formula. Okay, so in this case, I'm going to use the units because I know that this is the length. I know that this is the time. So in this case, my dimensions for velocity is simply L over T. Using the MLT concept, in this case, this is going to be -1. This is going to be 0. Okay. Dimensions of acceleration. Acceleration, let me use the units. Okay. I mean, in case maybe you don't know the formula, but you know the units, you can use that concept as well to give you the answer. So acceleration is in meters per second squared. So in this case, the dimensions of meters is simply a big letter L. The dimensions of seconds is a big letter T for period. Since there is a power 2, we put it like that. Henceforth, it is same as written as like that. Or if we put it in the MLT concept, which is the dimension formula, this is going to be our 0. Then this is going to be our -2. That is just how you find dimensional formulas of these particular questions. Okay, it's very simple. So I hope you understand and you found this video interesting. Consider subscribing and hit the like button, and don't forget to share to others.